Okay, good day everyone. Uh, we are discussing AC circuit single phase system. So we are now on part 6. No? My name is Engineer Reggie Marinay. Okay, so today we are going to discuss resonance AC circuits. Okay, what is resonance condition? Resonance, it is the condition existing in an RLC circuit when the applied voltage is in phase with the resulting current. No? What is the nature of this circuit? If the applied voltage is in phase, meaning the power factor is unity. Okay? There will be unity power factor. Okay? Because they are in phase. The circuit becomes purely resistive. No? For resonance condition. Resonance frequency. It is the frequency between the frequencies at half power points or the middle of the bandwidth of the circuit. Okay, so Q factor, it is the selectivity of the resonance circuit. It is the reciprocal of power factor. It is a measure. It is a measure of the degree of sharpness of the resonance curve, which represents the degree of the selectivity of the circuit. Okay, let's have the series resonance, no? Okay, what is a resonance curve? So we have a resonance curve here. Let's say this is the peak of the resonance curve. Okay. This is the frequency. Okay, let's say this is a current. Say. Okay. This is the bandwidth. Okay, so at this point, we reach the resonant frequency. We reach the resonant frequency. See? This is the bandwidth. This is bandwidth. You see? This is being applied by the electronics engineers in their communication. What is the application? One of the application is in the radio, in FM station. Let's have an example. Let's say, Wish 1075. Okay? You have your tuner in your radio, right? That's color red, right? You see the color red, no? You have your tuner here, okay? I want to listen to Wish 1075. 107.5. Actually, before the 107.5, that frequency, that is the resonating frequency of this radio station. No? Well, actually, before 107.5, no? That frequency, you have already a signal, right? So, meron ka ng signal na marireach doon eh. No? Okay? The 107.5. Okay? The FM station. That frequency. When you reach, actually, there is already a small signal, no? You already hear the station before the 107.5. But when you reach, slowly but surely, you reach the exact 107.5 frequency, then you will receive the maximum signal. Right? Maximum signal. That's very clear in the sound. Right? Okay? You will hear now Morissette singing. Chandelier. Okay? So, there. So, you will, let's say you exceed 107.5 frequency. No? Kilohertz, megahertz. Megahertz for the FM station. Kilohertz. Let's say you exceed 1075. No? Okay? That frequency, when you exceed that frequency, there is still a signal, but it is a decreasing signal here. Okay? So this is a bandwidth. What is a bandwidth? A bandwidth, no? Okay. We have here the resonant frequency. It's the frequency between the frequencies of half power point or the middle of the bandwidth. These 2 points are the 2 half power point, wherein you have a half power or signal. No? And the bandwidth, okay, you see, this is the upper limit and the lower limit of the half power point frequencies. Okay? This size is the bandwidth. At the middle of the bandwidth here, the magnitude, I mean, that is your resonant frequency. Okay. For series resonance, no? X sub L is equal to X sub C. The ZT is minimum. Impedance natin minimum. Let's say this is a current. Where is the impedance? The impedance is somewhere here. The impedance, let's say, is somewhere here. You see, that is upward. You see? The impedance is upward. This is downward. Okay? Okay? Did you imagine that? Never mind. Okay. So, when you reach the maximum point, this is the minimum point. This is the impedance curve. Okay? Let's say, if this is a current curve, this is a current curve, okay? Eh, wala. Yan talaga yung nasa mga libro eh. No? Nasa mga libro, nakasulat yan sa mga libro. No? Ewan ko ba yung iba, pag tinuturo ko to, natatawa yung iba eh. No? Sumobra yata imagination. So, eto ha, when you reach your minimum Z, no? Then you reach your maximum I. No? Minimum impedance will mean maximum current. Okay. Our current is equal to voltage over Z. If Z is minimum, our I is maximum, mathematically, right? Okay. So, our resonant frequency is 1 over 2 pi square root of LC. The Q factor, we have the formula 1 over R square root of L over C. Okay? Okay, let us solve number 21 problem. Okay, a resistance of the coil 100 ohms has an inductance of 20 millihenry. What value of the effective self-capacitance would make it accurately non-inductive at a frequency of 50 hertz? Okay? So, that is for number 21. No? So, for number 21, actually, using the formula of resonant frequency 1 over 2 pi square root of LC. That is the basic formula. The resonant frequency is 50 hertz here. So 1 over 2 pi. So square root of L. What is our L? 20 times 10 raised to negative 3. Then you have your C. Okay, you can keep solving your calculator. Anyway, I'll just give you the final answer here. That is 506. Is correct. 20 milli. Approximately. Is this 506? You can try, no? Try natin. Let's try. So we have here 1 over 2 pi. Then square root of L. So 20 times 10 raised to negative 3. Times alpha x. Okay. Okay, try natin. Let us solve, no? The capacitance is around, that is actually, in my calculator, that is 5.06066 0591 times 10 raised to negative 4. But if I'm going to make it as a microfarad, no? It's like in our choices. So we have 506.6. That will be times 10 raised to negative 6 farad. Or this is a microfarad, no? 506.6 microfarad. So, ganun ang mangyayari dyan, mga kawerpa, no? So, that will be a microfarad. Okay? 506. The answer would be letter D. Okay, so let's head now for number 22. A circuit consisting of a coil having an inductance of 0.25 Henry and a resistance of 3 ohms is arranged in series with a capacitor of 20 microfarad. Calculate at what frequency resonance will take place if an alternating voltage of 40 volts is applied to the circuit. So, we have that one, no, for number, what number? 22, no? For number 22. I think we have to draw our circuit here. Circuit consisting of a coil. Okay, so having an inductance. So we are given a resistance. So we have RLC, no? There. Our inductance is 0.25 Henry. Our resistance is 3 ohms. Our capacitance is 20 microfarad. Calculate at what frequency resonance will take place if an alternating voltage of 40 volts, that's the source, applied to the circuit, no? So, okay, what will be our resonant frequency? Again, just use the same formula as before, 1 over 2 pi square root of LC. Just substitute. Okay, so 1 over 2 pi square root of L, 0.25 Henry. Then 20 times 10 raised to negative 6. So what is the resonant frequency now here? (71.2 hertz). Letter C. That will be our resonant frequency. The answer is letter C. Okay? Let's go now to number 23. Okay, let's go now to number 23, guys. So we have here Or number 23. Okay, just the same given, right? So find the voltage across the capacitor. So we are just going to calculate the voltage across the capacitor. With, of course, the frequency, no? We are going to use the resonant frequency. Voltage across the capacitor. Our X sub C, I will get first our X sub L. Just want to show you this one. So that is 2 pi. Resonant frequency is 71.2 times the inductance is 0.25. So our X sub L is how much? I'll give you the value. So X sub L is 111.8 ohms. There. Okay. What about our X sub C here? That is 1 over 2 pi, then 71.2, then 20 microfarad times 10 raised to negative 6. So the answer is 111.76. Actually, they should be the same because that is at resonance frequency. At resonant frequency. Always remember, at resonant frequency, no? The Z is equal to R. How is this, sir? Okay. So plus, let's say we have X sub L minus X sub C squared. Well, of course, if they are just equal, so the difference is just 0, right? So if that is 0, that will just become square root of R squared. What is square root of R squared? Of course, that's simply equal to R. So therefore, Z is equal to R. That is why our impedance is minimum. Okay? During the resonant frequency. Okay? That is minimum. Okay, now, let us find for the current. What is the current now? Our I is equal to V over Z. What is our V? That is 40, right? 40. Our resistance is simply 3. 40 over 3. So that is 13.33 amperes. Right? So, V sub C is simply by Ohm's law, the current, 13.33 times X sub C, which is equal to 111.76. So our answer is 1490.67 volts. That is the answer for B sub C. No? 1490 or simply letter C. Got it? Nakakuha po ba yan? Nakakuha? Okay, so let us have the parallel resonance circuit. Parallel resonance is also known as the anti-resonance circuit. So we have here RL and we have our RC, no? Wherein our beta sub L is equal to beta sub C, no? For this kind of circuit, no? Parallel resonance, no? Okay, that is opposite of the series resonance. That's why it is called as anti-resonance. So, the maximum, the impedance is maximum. The current is minimum. Earlier, the impedance is minimum, right? The current is maximum. But in parallel resonance, no, it is the exact opposite of the series resonance. No? Baliktad sila. The resonant frequency for that circuit, RL and RC, resonance. 1 over 2 pi square root of LC, square root of RL squared C minus L. No? Divided by RC squared C minus L. The Q factor is the current in L or C branch. No? Why is this? No? Because the current here in the L branch is simply equal to the current in the C branch. No? At resonance condition. Okay? Always remember that. Okay, this is just a summary of the resonance, no? Well, you have that in your handouts, no? Okay? So our reviewees. Okay. So for numbers 24 and 25, the following information is given in connection with the two branch parallel circuits such as in the figure shown. So we have a figure, no? We have RL10, RC20, X sub C40, our E is 120, our frequency 60 Hertz for the condition of the resonance. So there you are. This is the figure. Okay? Okay? So let us draw this figure that is simply parallel RL and RC. Okay, so let us write down the given. Our RL is equal to 10. Our RC is 20. Our X sub C is 40 ohms. That is automatically in ohms. X sub C is 40. So there's no X sub L here, no? That is question mark. Our supply voltage E is 120. Then the frequency is 60 Hertz. Okay, take note of that. Okay, calculate the two values of the inductance. So, kukunin natin yung dalawang value ng inductance, no? Take note that beta sub L is equal to beta sub C. Take note of that. We have here X sub L over RL squared plus X sub L squared. That is equal to X sub C over RC squared plus X sub C squared. Okay. We just have to substitute. No? So this is X sub L over, what is our RL? 10. 10 squared plus X sub L squared. So that is equivalent to X sub C, which is 40, right? 40. Then RC is 20, right? 20 squared plus 40 squared. No? Okay, I already solved this. No, I'll just give you the value. No, you can verify in your sheets. Okay, just give you the value here. So we have here our, let's say we have our X sub L. So there will be two values, no, because this will become a quadratic equation, right? These two values. There will be two values, XL1 and XL2. Okay, you have to use our algebra, no? So we have here XL1, we have 47.91. 0.91. Our XL2, so that is 2.087 ohms. No? Okay. So, we have here our L1. Let's calculate for our L1. So, we have 47.91. That is equal to 2 pi 60, right? Then L. We have this value, 0.127 Henry. Okay? For XL2, this portion, We have 2.087, that's equal to 2 pi 60 L. Let's say this is L1. The second value of L2 is 0.0000554. Okay? You can send your message in our chat box. No? If you see some a bit mistakes, no, or a typo error, you can remind us, no, by partner, sabihin mo sa akin, ha? Kasi baka mamaya may makita kayong mali dito or what, no? So still, I don't want to erase that possibility, no? So, tao lang tayo, no? Nagkakamali din naman, no? Pero wag naman madalas, no? So, okay. So, anyway, we already have the answer, right? That will be letter B. O, yan ang sagot natin, mga kawerpa. Bahala na kayo dun sa mga math portion, no? Kasi sa math portion natin, kung iisa-isahin natin, eh, naku, abutin tayo ng ano rito, no? Okay? So, I already calculated these values, no? So, you just verify in your sheets. Okay. Number 25. Calculate the two values of the line current. Huh? Where is line current? Of course, this is the line current, no? That is the line current, no? The total current, no? That is the line current. Okay. I'll show you a direct formula, no? So, dediretsuhin na natin yung formula. Okay. So, the total current, what number is that? 25. Okay. So, the formula will be, the total current is equal to the total voltage multiplied by the total conductance, G. At resonance frequency only. Okay? Sa resonance lang yun, ha, mga kawerpa. Okay. Yung ating total, of course, this is total voltage, isn't it? That is the total voltage. I'll show you the formula. Of course, our GT, remember that our GT is equal to, okay, I'll just put it here, V total, okay? So, this is our GL plus GC. Okay? GC, no? Group chat. Okay. Google Classroom. Okay. Na-check nyo na ba yung mga files sa Google Classroom natin, no? So, check nyo na. So, RL over RL squared plus XL squared. This is the formula, no? So, sinusulat na natin lahat. I'm writing down all the formula here. Just substitute. Then, we have here RC squared plus X sub C squared. Okay, close bracket. Okay, let's have first the I total 1. That is just the first line current because there are two values for the inductance, right? And X sub L. So, we have 120, no? We have 120. Okay. We have 120, no? Okay. So, we have here our RL, that is 10 over 10 squared plus X sub L. Diba X sub L natin? O, yung una nating X sub L is 47.91 squared. No? Then plus, what is our RC? 20. No? Okay, ito, 20. Yung RC natin. Over 20 squared plus X sub C, 40 squared. Okay. All of these are just by magnitude. There's no J here. Just calculate this, then multiply by 12. So therefore, our I total 1 will be equal to, I'll just give you the final answer for this. 1.701 amperes. That's one of the answers. What about the I total 2? Okay? That is for x sub L2. So that is 12. Again, 10 over 10 squared plus, substitute, substitute, okay, 2.087 squared, then plus, we have 20 over 20 squared plus 40 squared. Okay? So what will be our answer here? Ano yung 120? Yes, 120. Ito. Okay, nagkamali yung ating nagkamali yung marker. I'm sorry, no? Okay? So, this, no? Tao lang. Okay, sige. So, ano kasunod natin? Ilan to? Pag kinalculate mo. So, 12.69. 12.69 ampere, no? Ayan, mga ka-aware pa, ha? So, therefore, our answer would be, okay. So na, may sagot na tayo. Letter C. That is our answer, no? Okay. Konti na lang po ito. Kapaso na lang. Mga ano na lang po, 15 minutes, no? And 3 hours. Okay, so let us go with number 26. Let's go with number 26. Calculate the resonant frequency of a two-branch parallel circuit given the following particulars. Okay, so all are given, RL, RC, we have the L and C are given, no? So given na lahat siya. Actually, there's just a direct formula for this sample problem. Okay? So, for number 26, for this number 26, I'll give you the formula for number 26. The resonant frequency is 1 over 2 pi square root of LC. Then, square root of RL squared C minus L over RC squared C minus L. So, that will be our formula. I'll just substitute all the given values here. 1 over 2 pi. Substitute lang po natin lahat yan. This is just a direct substitution problem. So, we have our L that is 0.254. Our C is 40 times 10 raised to negative 6. Okay. Then, we have now the square root of RL squared. So, RL, we have 40 squared. So, we have C, right? Anyway, what is our C here? 40 micro. Okay, you can put the sign micro. But in your calculator, go directly with times 10 raised to negative 6. No? You know what I mean already. So, we have here 0.254. RC, 20 squared times 40 micro minus 0.254. I'll just give you the final answer for this. .6 hertz. And that would be letter. So what letter is this? Okay, there you are. This is cycles per second. No? That is 26. Okay? Then let's go now to number 27. From the previous problem, at what frequency will the circuit be in resonance? Be in resonance if RL is equal to RC. Assume L and C remains unchanged. So, if RL, take note here. Let's take a look at the formula here. If RL is equal to RC, what can you say here? If they are just equal, RL is equal to RC. This C minus L is just the same here, right? So everything here, okay? So, what will happen? The L and C remains unchanged. This will become 0, this will become 0. This is negative L over negative L, that is 1. Square root of 1, that is simply 1. Although when you extract a square root, there should be, what is square root of 1? 1? That's wrong. It should be plus or minus 1. When you extract a square root, there is always, should always be a positive and negative sign. But for this case, if they are just equal here, that will just become square root of negative L divided by negative L. So therefore, it's just simply 1. What will be left is just this formula. No? 1 over 2 pi square root of LC na lang ang matitira. So, we have our L, 0.254 times 40 micro. So, our answer for number 27 is 50 hertz. Cycles per second. Okay? So, well, that's it for our resonance topic. Thank you. Salamat po sa inyo.